Today I'm going to do a tier list on space startups that are working on in-space operations. That is, they're working on the orbital economy, so that could be cargo services, power beaming, communications, space stations, and a whole series of different things. But basically, I'm going to talk about 30 different space startups and group them into different categories. But before we get into that, just put this banner up on the screen. So we're on X, so please follow at Space Startup Hub if you're on X. And I post notifications of my videos on there, so that'd be great. So without further ado, let's get into the tier list, and I'll bring it up here and put myself in the corner. I think it's okay there. As you can see, there's quite a few companies. This is not going to be comprehensive. There are some companies that I've not included for one reason or another. I'm not including major aerospace primes. I'm not including SpaceX, for instance. This is, I don't know if you can read it, but this is ATMOS, which is a German space startup. They're working on what they call an IAD, or Inflatable Atmospheric Decelerator. The idea is you have cargo, you're manufacturing something in space, and then you want to return it to Earth. So this inflatable device will re-enter the atmosphere. It will inflate using the air in the atmosphere and gently land, and then you can recover the cargo. They've already tested a demo in space. This particular render is based on an RFA, or Rocket Factory Augsburg cargo vehicle, which is just a concept. It doesn't exist at the moment, but the IAD from ATMOS does, and it's under development at the moment. So let's have a look at this one. This is Sierra Space's Dream Chaser, which I think goes into the space tug cargo category. It's for ferrying cargo to and from space stations. Potentially it could be upgraded in the future to carry crew, but at the moment it's just cargo. Let's talk about this company here. This is Rendezvous Robotics. By the way, a lot of these companies I've done a dedicated video on, so if you want to know more about any of these companies, just have a look at the channel and you'll probably find a video. So Rendezvous Robotics is working on self-assembling tiles. You can release them into orbit and they will find each other and assemble together. This technology has already been tested on the International Space Station multiple times. I think it's on version 5 now. The next test will be dinner plate sized tiles that should link up to form an enclosed sphere. So the tiles, when they're all assembled, will actually make a sphere in space. So you could potentially make very large structures using this kind of technology. So let's think about the next company. So Varda Space is also cargo, I think. So basically you can see here there's a cargo return vehicle. There's a re-entry capsule. You can see the parachute there. So Varda Space allows customers and clients to manufacture pharmaceuticals or drugs in space. And once the manufacturing is completed, the capsule separates from the satellite bus, re-enters the atmosphere, and then a parachute is released and it gently falls back to Earth. So they've done this 5 times now. They've had 5 re-entries. They've managed to recover all of them. So they're kind of no longer in development and are now in operations. They've had 2 of these vehicles in space at the same time. So they're gradually increasing the cadence of operations. And their operation is now more vertically integrated. In the past, they had a satellite bus produced by Rocket Lab. Now they produced their own re-entry capsule. And they're automating the entire process of re-entry to scale up operations. That's Varda Space. Think Orbital belongs in the construction assembly category. They are using electron beam welding robots to assemble metal sheets into pressurized habitats. So the idea is you'd send a stack of sheets, flat packed, into space on a Falcon 9 or perhaps a Starship in the future. You'd also send a robotic arm, and at the end it would have an electron beam welder. It will attach the tiles, link the 2 tiles together, and then weld them together. And you can continue doing that until you've got a sphere. And these spheres can be 20 meters across, which would provide a pressurized volume of 4,000 cubic meters, which is 4 times the size of the International Space Station. So that's Think Orbital, which is a US space startup. I'd also put Space Quarters, which is a Japanese space startup, in the same category. I don't have a tile for it. But basically, it's exactly the same concept, including using an electron beam welding robot. So it's exactly the same idea, but a Japanese company instead. So here we have Overview Energy, which, as you can see from the render, is basically solar power collected in space and then beamed down to Earth. So this can be beamed down to solar farms, and this energy can be beamed down to existing solar farms and supplement the solar energy. For instance, at night, when these solar farms don't generate any electricity, you could contract Overview Energy to beam down energy from space to the solar farm. There's no need to change the solar panels on the ground at all. So that's space-based solar power. While we're talking about that, there's another company, if I can find it in the list. Yes, here it is, Space Solar. And this is a UK company that is also working on very large space-based solar power. These would be kilometer-sized satellites with millions of solar panels that would beam down microwaves to the ground, and you'd have a rectenna on the ground, and this rectenna would also be kilometers in size, and you could receive megawatts or even gigawatts of power. Each one of these satellites would be potentially several kilometers in size and generate hundreds of megawatts and potentially in the future gigawatts of power. And when it's over the rectenna, it beams down the energy. This is a very large scale concept for space-based solar power. We also have other companies working on power beaming, but on a much smaller scale. And here's an example of that, Starcatcher. So their idea is not to beam the power collected from the sun down to Earth, but to beam it to other space assets, such as satellites. So this would give the satellite more power, or power when it's in the Earth's shadow, which means it could run its communication system or its imaging systems at higher power or high resolution or more often. So that's Starcatcher. Another example of this is Aetherflux. This is another power beaming company. Their idea is to collect energy from the sun and beam it down to military outposts or remote bases which are off the grid and are difficult to resupply. This is an infrared laser link. The receiver is quite small. I think it's only a few meters in size. So potentially this could be used for moving targets such as ships, cargo ships, anything that can host a receiver that's a few meters in size. They've also pivoted to orbiting data centers. That's the galactic brain concept. So they're continuing with their power beaming mission, but they've also added another project called Galactic Brain, which is to build orbiting data centers in space, which do AI processing and beam the results down to Earth, or potentially to other satellites. So this is similar to SpaceX's idea for orbiting data centers, or Google's Project Suncatcher, and so on. In terms of space stations, we have Blue Origin's Orbital Reef. This is a very large commercial space station, something like 800 cubic meters of internal volume. I do believe it's probably on the back burner because Blue Origin has a lot on its plate already. It's already cancelled or paused New Shepard, its suborbital flights, after a visit by Jared Isaacman. So I think NASA has put them under pressure to get the lunar landers working as quickly as possible. That means shelving or pausing non-essential contracts. And I think Orbital Reef is probably in that category as well, to be honest. So I'm not really expecting to hear that much from Orbital Reef in the future. Talking about commercial space stations, we have Starlab Space, which is probably my favorite commercial space station at the moment. It used to be Varda Space, but that's been delayed by another year. And Starlab Space has a lot of private investment, a lot of equity partners. It's a very large station, about 400 cubic meters, with 130 payload lockers. So it has the same research capability of the International Space Station, while being less than half the size. It should be a very efficient station with the software and AI systems built by Palantir. It will be serviced by the Cygnus cargo vehicle from Northrop Grumman. It will have a robotic arm from MDA Space. And some of the key partners are Airbus in Europe and Mitsubishi in Japan. Talking about space stations, we also have Max Space, which will probably compete for the Phase 2 Commercial LEO Destinations Award from NASA. It's an inflatable design, and they have plans for Mars and the Moon as well. Their inflatable design will be quite large. It'll be about 400 cubic meters in volume, with 2 docking ports and lots of space for research and science. In terms of propulsion, we have Portal Space Systems, which are working on solar thermal propulsion. So this vehicle doesn't move by combustion. All it does is heat up a propellant and then eject it from the vehicle at high speed, and that propels it forward. They'll probably use something like ammonia to begin with. You could also use water. But in the future, For efficiency, they will probably switch to hydrogen at some point, because hydrogen is extremely light, which means you get very high exhaust velocities, which means you get very high fuel efficiency. So this will have a pretty good delta V, maybe 4 to 6 kilometers per second. The US Space Force is interested in this technology. They have funded it by various awards. So this is a new kind of propulsion technology that reflects the sun's energy onto a heat exchanger, which gets extremely hot, and it expels the propellant at very high speed. And this is kind of a bridging technology towards nuclear thermal propulsion, which is very similar concept, but instead of using the sun to heat up a propellant, you use a nuclear reactor. Talking about space, tugs, and propulsion, we have Impulse Space. This is by Tom Mueller. He's the CEO, and he was SpaceX's employee number 1. He was the chief engineer for SpaceX, and he designed the Merlin engine that's used on Falcon 9. So he's very good with engines, and he's working on a space tug company. So they already have space tugs in orbit. They have the smaller Mira space tug, which gives you maybe 1 to 3 kilometers per second. They're working on a more powerful space tug called Helios, and that's capable of 4 to 6 kilometers per second, which means you could potentially send payloads towards the moon. And in fact, they do have plans for a lunar lander, but their main business is space tugs. Back towards commercial space stations, and we have Vast Space building Haven 1, which should have launched this year, but has been delayed a year, so should launch in 2027. It will still be the first space station in orbit if it launches next year. And they have plans for Haven 2, which is the station they will propose to NASA for the Commercial LEO Destinations Award Phase 2. You can actually see this is Haven 2 because it has 2 windows. Haven 1 just has 1 window and 1 docking port, but it supports up to 4 crew for 30 days. Haven 2 will be bigger, and you can chain them together to make a larger and larger space station. And in the 2030s, they have plans to spin the space station around to create artificial gravity. In terms of manufacturing and forging, we have Space Forge. And what you're looking at in that image is a furnace in space, and the temperature inside the furnace is 1000 degrees, which is hot enough to melt aluminium, of which there is large amounts in space already. So the idea is that you can manufacture alloys or materials in space to very high levels of purity. For instance, silicon you can manufacture without the defects you get on Earth. Because it's more pure and doesn't have defects, it will be more valuable. They've already proved their furnace works in space. I'm not sure whether the next satellite will be a commercial operation or they're still in the testing phase, but definitely they're making a lot of progress. I'm going to put Astro Forge here. The idea is to fly to asteroids and mine asteroids for materials and then send them back to low Earth orbit, but where potentially they could be then melted down or processed further for in-space materials, or if they mine gold or precious metals, they could perhaps return to Earth and sell those metals. So they've had a number of satellites in space, but they've had technical difficulties. But they're well funded at the moment, so they're working on their 3rd satellite, I believe. In terms of servicing, we have Orbit Fab, which is working on propellant depots. You'll be able to go to one of these propellant stations and top up on oxygen or stirrable propellants. At the moment, not cryogenic, but perhaps in the future they will be able to sell cryogenic propellants. Potentially water as well, or consumables, or xenon, or krypton. And also they have these fuel carriers, so the actual fuel shuttle can go from the station to your satellite and refuel the satellite, and then go back to the station. So it can work either way. And they already have a sale, I think, to the US Space Force for, I think it was hydrazine, for one of the US Space Force satellites. So that should be flying in a year or 2. So I'm going to put K2 Space down here. It is a satellite, but it is a very large platform satellite with a lot of power. So this would be perfect for power beaming, communications, or orbital data centers. The satellite bus has been re-architected from the ground for high power operations. It will have 20 kilowatts of power. I believe each one of those solar arrays is 20 kilowatts, so like 40 kilowatts. And it can be scaled up to 100 kilowatts. They have a mega class and a giga class satellite bus. And also Jared Isaacman, I think, is interested in this company because potentially if you added a nuclear reactor, you could have a nuclear electric propulsion spacecraft. It's architected for high power operations, which is what you would need for a nuclear electric propulsion. Because of its large size as well, I think this would be a perfect platform for the very first nuclear-powered spacecraft. We also have Astro Scale for servicing. They're working on remote proximity operations and docking, potentially for orbital debris removal, or life extension, or end-of-life operations for satellites, moving them into graveyard orbits, for instance. So they're working on a number of projects, some with the UK Space Agency, the Japanese Space Agency, and also some commercial clients such as Intelsat. Here we have Nix, the Nix cargo vehicle by the exploration company. That's a French-German space startup that's very well funded, and they're working on a cargo vehicle. They have a contract via ESA, the European Space Agency, to send cargo to the International Space Agency in 2028. They also have agreements with Varda Space and Axiom Space to potentially send cargo to and from their commercial space stations. They also have plans for the moon with a moon lander. Their plan is to be Europe's SpaceX, so we'll see how that goes. For servicing, we have Starcloud, and they're working on orbiting data centers. So they've been working on this concept for several years. They're the first startup to have this idea, long before Elon Musk mentioned it. They have Starcloud 1 in orbit already. They should be launching Starcloud 2 at the end of this year, October 2026. And they recently announced Starcloud 3, which will be a 40 megawatt orbiting data center. So it'll be 200 satellites. Each satellite will have 200 kilowatts of power and will have a cluster of GPUs, but together operating as a cloud, it'll be 40 megawatt data center. Spaceium is a competitor to Orbit Fab, so it belongs here, I think, in terms of services. It's working on a propellant station. They're not as advanced, and we don't really get a lot of social media posts from them, but they have funding. The more competitors, the better. We have here Karman Plus, which are also working on asteroid mining. So they're a competitor to Astro Forge. So their idea is, again, to mine asteroids and extract useful materials. It could be water, it could be volatiles, or it could be metals or minerals. In terms of commercial space stations, there's also Axiom Space. They're working on Axiom Station, and their idea is to gradually assemble a space station, one module at a time. The very first module will be attached to the International Space Station, then it will separate at a later date, and it will keep adding modules. We also have Gravitics, which is working on space station modules, but not to be an operator of a commercial space station, just to sell their modules to other operators. They have a contract with Axiom Space for one of their modules. Starfish Space is working on remote proximity operations and docking. They already have one of their tech demos in space just to test the technology, and they're working on scaling that up to their full commercial satellite. Cislunar Industries is working on metal foundries in space. So similar to Space Forge, the idea is that it will melt down metals in space and reforge them or extrude them into useful parts or components, one of which could be metal propellant rods, which can be used for propulsion. So talking about metal propulsion rods, we have two space startups that are working on propulsion drives that use metal. So we have Neumann Space from Australia and Magdrive from the UK. They used a pulsed arc thruster. This arc device turns metal rods into plasma, which is ejected from the spacecraft at high speed, generating thrust. And then we have Exlabs, put that at the end here, but also they're in partnership with Antares. Antares builds nuclear reactors for space and also for the moon. Exlabs is working on modular spacecraft that can travel in deep space, and these are modules that you can stack together to make the spacecraft larger. They also mentioned about having a nuclear-powered spacecraft. So this is the partnership with Antares. So the idea is one of those modules could be a nuclear reactor. So there you have 30 space startups that are working on in-space operations, with Elon Musk planning to launch 1 million satellites into space every year for his orbiting data centers. So currently the failure rate for a satellite for Starlink is about 1%. So 1 million satellites per year means 10,000 satellites have to be dealt with. They have to be deorbited, they have to be put into a graveyard orbit, they have to be potentially repaired or upgraded. Potentially these could also be refueled as well. With a vast increase in satellites due to orbiting data centers, there's a lot of potential business for these companies working on space tugs, or refueling, or power beaming, or commercial space stations, or new propulsion drives. So it's a very interesting time in space, And I think that's only going to increase as well for the moon, with Elon Musk now saying he's going to focus on the moon base. So that would potentially be hugely beneficial for lunar space startups. But this video is really on space startups that are focusing on in-space operations, on the orbital economy, which I think is just going to get bigger and bigger over time. So anyway, that's the video this week, and I've not done a tier list in a while, so I thought now was the time. So thank you for watching, and please like and subscribe, and I will see you next time.